Welcome. Now that we've had a chance to look at the different methods of factoring or the different types of polynomials and how to factor them, we're going to put it all together in this section 5.6. This is section 5.6. We're going to put it all together. Remember, the first step of factoring is to look for a GCF. If the greatest common factor is not 1, so if the greatest common factor is not 1, your first step should be to factor that out. If you have a leading coefficient, and remember to put your polynomial in standard form, that will make it so much easier. So make sure your polynomial is in standard form. If the leading coefficient is negative, there should be a comma right here. If the leading coefficient is negative, factor out a negative with the GCF or factor out a -1. It's going to make it so much easier to factor when we have a positive leading coefficient. So we'll factor out a negative if that leading coefficient is negative. All right, so the steps. Step 1 is factor out a GCF and negatives if needed. Step 2, do you have a binomial, a trinomial, or do you have 4 terms? Remember, binomial has 2 terms. This is 2 terms. Trinomial has 3. If you have 4 terms, you're going to use grouping. So if it's a binomial, you're going to look to see if you have a difference of squares. And remember how to factor a difference of squares. A squared minus b squared is a plus b times a minus b. We've got the pattern written right here for you. If it's a trinomial, now you've already looked for the GCF. So if it's a trinomial, remember to calculate a times c. And then you find your pair of numbers that have the same product as a times c, but they add up to b, right? You know this process. We've been doing this. So there's a reminder of how it works. If you have 4 terms, you're going to factor by grouping. You can either group with parentheses or you can use the box to help you with the factoring when you have 4 terms. And then something that's important is at every step, you need to ask yourself, can any of the factors be factored more? Can we break them down further? Okay, so when we say factor completely, we mean take every term, every factor, not every term, but every factor, take every factor and break it down as much as you possibly can. Okay, so we're going to just jump into the examples. And we're going to work with example 1. Do you notice it's in standard form? So here's example 1. Highest power here is a square. And then we have a 2. So we have a power of 2. And then we have a power of 1. We just don't write the 1. And then we have the constant. So it's in standard form. But do you notice the leading coefficient is -7? So we're going to factor out a negative. But let's look for a GCF as well. So 7, 21, and 28. Those are all divisible by 7. So as I factor out the negative, we're also going to factor out the GCF, which is a 7. So let's pull out a -7. So if we take the -7x squared and divide out the -7, that leaves the x squared. If we take the -21x and we divide by a -7, that turns into a positive. -21 divided by -7 is +3. So there's that sign change. And then lastly, the 28, it's a +28, but we divide by -7, we get -4. And then you can double check and make sure you haven't made any mistakes by redistributing the -7. Okay? Now we forget about the -7 for a bit and we factor what's inside the parentheses. Well, what's inside the parentheses? We have a equals 1, b equals 3, and c equals -4. Right? A times c is -4. So we're going to do a times c. And we're going to look for 2 numbers that have that same product, but I need them to add up to 3. That's what I need for the sum. They need to add up to 3. So let's see. I don't have a lot of ways of getting 4, -4, right? One of them has to be positive, one of them has to be negative. But if the sum is 3, I need the bigger number to be positive. So I've got 1 and 4, One of them needs to be negative, and the negative needs to be on the smaller number. So negative 1 and 4, does that add up to 3? Yes. First time, try. We got it the first try. Okay, now what we're going to do is we're going to draw our box. You can use grouping if you learn grouping, or if you have another method that you want to use that you were taught or that you've discovered. You can use the methods, but I'm going to just use the box. So remember the first term, x squared, gets the first piece of the box, the first square in the box. And then the middle term, I'm splitting into a negative 1x and a 4x. And then lastly, we have the negative 4. Okay, so our 3x turned into a negative 1x and a positive 4x. Now remember to find the GCF for each row. Top row is x, bottom row is 4. Find the GCF for each column. Okay, maybe I'll change colors here. So now I'm working on the columns. I'm going to find the GCF for that. That's x. I'm going to find the GCF for this. This is a negative x, so I'm going to pull out a negative 1. And then I'm going to check before I move on and make sure that it worked. Because remember, this is a multiplication table. So x times x is x squared. X times 4 is 4x. Negative 1 times x is negative x, and negative 1 times 4 is negative 4. It worked. Okay, so final answer. Well, let's make sure it is the final answer before we call it done. But my factors are negative 7. Don't forget the negative 7 that we had right here. Okay, that negative 7 needs to be part of my answer. X minus 1 and x plus 4. Do either one of those new factors, x minus 1 or x plus 4, break down any further? No. And we're done. Okay. I think I'm going to draw a line through here, maybe in a lovely purple, to kind of separate the different problems. Okay. I'll draw it further in a little bit. Okay, second example. Example 2. Remember, look for a GCF first. Oh, look. 4 and 40. They're both divisible by 2, but 40 is 4 times 10. Oh, I can get a 4 out of that. So I'm going to factor out a 4. And then I have, let's see, 4x squared. Well, that's 4x squared. Divide it by 4, you get x squared. 40 divided by 4 is 10. Notice the negative sign in between. Let's see. What was my rule? If it's a binomial, look for a difference of squares. X squared minus 10. Oh, it's not a difference of squares because the square root of 10 comes out to some strange decimal. You can grab your calculator, do the square root of 10. It comes out to 3.16. It's not a perfect square, right? Square root of 10, it's not a whole number. So that's not going to go any further, right? So we are done right here. Okay, next example, example 3. I need a little more room, so we get a little more room. Okay, example 3. Do you notice what we have? We have 4 terms this time. 1, 2, 3, 4. I need to look for a GCF. Do those 4 terms have a GCF other than 1? Nope. GCF is a 1, but we should always look. So what we're going to do, I'm just going to build a box right away and factor using the box. So I'm going to draw a box. And I'm going to factor using the box. Let me move the box up. I really don't need that much space. I'm struggling here. I'm going to have to scroll down again. Okay. So I'm just going to move the box up. First term gets the first square. Next term, last term. Okay, find the greatest common factor for the top row. So here's my top row. That GCF is an x to the 3rd power. Bottom row. 12 is divisible by 4, so that GCF is a 4. Next, we're going to do the first column. So this is where I'm looking at this column right here. GCF there. And since yellow doesn't show up really well, I'm going to switch back to blue. X. We got an X. And then for this last column, it's -3. Now I'm going to check to make sure my multiplication works. X times x to the third is x to the fourth. So right here, this times that is x to the fourth. And -3 times x to the third is -3x to the third. X times 4 is 4x. -3 times 4 is -12. It works. So I'm going to write down my factorization. X minus 3 times x to the third plus 4. I've got a binomial times a binomial. X to the third plus 4 is not a difference of squares, and I can't factor that. Okay. And we're done. Example 4. Final example. So the first thing I'm going to do is notice that it's in standard form. It has 2 terms. Oh, I'm going to look for a GCF. That's really should be my first thing. Standard form is always good, so you could do that first if you wanted. But it's already in standard form. GCF is a 3. So I'm going to factor out a 3. That's x squared minus 100. The 100 is 10 squared, so I'm going to factor that as a difference of squares, because that is 10 squared. All right. So for my a, I'm going to use x, and for my b, I'm going to use 10. There's my a squared minus b squared. Let me move this down a little bit. So remember how it factors. A squared minus b squared factors as a plus b. So I'm replacing the a with an x, the b with a 10. And then a minus b. So they're almost identical. One has the plus, one has the minus, and we are done because x plus 10 and x minus 10 are not going to break down any further. And that is the 5.6 notes.